The Chameleon Ultra is the world's smallest RFID emulation device, featuring advanced capabilities like low and high frequency emulation, cutting-edge cracking technology, and wireless control, all packed in a compact, kitchen-sized, fully open-source device. Today's video is how to Chameleon Ultra. Hi, my name is Sandy from lab41.com. Today I am joined by GameTec-Live, the talented teen programmer behind the Chameleon Ultra GUI, and we will go through all the settings of the app on PC, Android and iPhone for you. To begin with, where to download the app. For iOS devices like the iPhone, the iPad, iPod Touch and the macOS X 10.14 or later, you can download the Chameleon Ultra GUI from the Apple Store. The direct link is available here. Additionally, you can join Test Flight to get earlier builds of the application. For Android users, the Chameleon Ultra GUI can be downloaded from the Google Play Store. The direct link of the app is here. There is also an option to download a plain APK version if needed. The Chameleon Ultra GUI is available for Windows, Linux and macOS. You can download it for these platforms from the Chameleon Ultra GUI GitHub page. Additionally, for Windows, you can use an Android emulator to download and install the Chameleon Ultra GUI on your computer or laptop. Now that the app is installed on your device, you need to connect the Chameleon Ultra. For that, you can use two methods, using a USB-C cable and plug the Chameleon Ultra to your device, or connect through Bluetooth. Bluetooth allows a wireless connection on mobile devices, iOS and Android, but it is way slower than a wired connection. A wired connection, on the other hand, is faster and more reliable, especially when you are working in an area with strong RF interference, but you're tethered on your device. Note that wired is the only way to connect on desktop devices, as there is no Bluetooth library support for desktop. When connected, open the app, an image of the device connected will appear. The app will control the Chameleon Ultra, the Chameleon Ultra Lite, and the Chameleon Ultra Dev Kit. Also note that an image of the Chameleon Ultra will be displayed when you are using the Chameleon Ultra Dev Kit, as there is no way to differentiate the Dev Kit from the Chameleon Ultra. To interact with a connected Chameleon, just click or tap on the image. Note that if there are multiple Chameleons plugged or at Bluetooth range, they will all show up on that page. When connected, the app will let you know if you are running a 1.0 version of the firmware and offer you to update it. You can update or skip. The app design is pretty intuitive. There is a navigation bar on the left side showing 6 pages. By default, you will be on the home page, of course. The right side of the screen will display the functions you can control on each page. The 6 pages are home, so the home page, the slot manager, the page to manage the 8 slots of the device, 8 high frequency, 8 low frequency, assign cards to the slots and choose emulation modes, etc. Then you have saved cards, where you can find your saved cards, of course, but it is also the location of the dictionaries. Then you have read cards, where you can read cards, of course, crack them, use dictionaries to get missing keys and save them. After that, we have write cards, the menu to go if you want to write on a blank card. And finally, the settings page. On that page, you can access the language, UI design and settings management, so import, export, the about of the app, the build version and much more. We'll check all that in details. The homepage will display crucial information about the Chameleon device. On top right, the USB port number or Bluetooth ID used to connect to the app. Then you have the battery level and the voltage. You can see the type of device connected, the used slots indicator, so 3-8 will mean 3 are used from 8 possible, the 8 slots of the device, with different colors for the ones that are used and the ones that are free, with arrows on the left and right side to select a slot. You can see the image of the device, the current firmware version and an icon to check for firmware updates. You can also find a switch from reader mode to emulator mode. As you may already know, the Chameleon Ultra has 2 chips, the NRF52840 that handles emulation and a MFRC522 handling the reading and writing. By the way, the Chameleon Ultra Lite is missing the MFRC 522. So switching between those modes switches who is in charge of the antenna. On the Chameleon Ultra dev board, you can actually hear the relay click and therefore also switches the possible actions. The Chameleon Ultra GUI does its best to handle the switching automatically, but in case it is required to switch manually, this button does it. Finally, you can access the device settings using the settings wheel at the bottom right of the page. Let's take a look at the device settings subpage. Here you can access the firmware management. You can enter DFU mode. As you may already know, DFU stands for Device Firmware Update. This button is intended in case you want to manually switch to DFU and then perform DFU actions outside of the app using an RFUTL or similar. It's not limited to just doing firmware updates. The second function is flash firmware via DFU. In this mode, the device will enter in DFU mode and flash to the latest firmware. It connects to the internet and download and install the latest firmware from the official GitHub. The third function is flash.zip firmware via DFU. If you want to install a custom firmware, you can choose this mode. Simply click, select the zip file with your custom firmware and flash. Next, we have the animation control. Full is the full animation mode, mini it's a shorter animation mode, and none is no animation at all. The animation is being played when the device wakes up, so when you select no animation, the device starts up instantly. That might be the best option. Then we have the button config. There are two buttons on the Chameleon Ultra, button A and button B. Two states of the button press will be configurable: normal press and long press. Long press is around 3 to 5 seconds. There are 5 statuses that you can assign to each state of button A and button B. Disable will disable the function, so nothing will happen in that state. Forward will switch the slot forward. Backward will switch the slot backward. Clone UID will clone the UID of the card or badge. Charge will display the current battery charge using the 8 slots LEDs. Now you can simply assign a mode for each button for normal press and long press. Next, we have the BLE functions. By default, the BLE pairing is disabled. When enabled, the Bluetooth pairing is enabled, allowing you to restrict who can connect to your device, so they need to know the PIN, of course. You can clear the bounded devices and change the password. Finally, in Other, you can reset settings. It will reset all the settings above, or factory reset. It will reset the device to its original factory state. Okay, let's change the page and go to Slot Manager. In this page, we can see the 8 slots displayed with the basic information: the slot number, the tag name in the high frequency spot and the low frequency spot, and the settings wheel per slot, redirecting to the slot settings. To assign a card to a slot, simply click on the slot that you want, then you will see a list with the saved cards. Note that this icon means it's a low frequency dump, and this one means it's a high frequency one. Click on the card, and the dump is automatically assigned to the LF or HF spot of the slot. Let's take a look at that slot settings. On the top right, you can find the export slot data. You can choose the frequency slot to export, low frequency or high frequency. After choosing the frequency to export, you can decide to save to file, to save locally. Export to new card will create a copy that you can name. Very useful after you made changes to the card with the edit slot data. You can also decide to update the saved card. Back to the slot settings. It showcases the HF and LF spot, followed by the name of the card assigned and a switch to deactivate the spot. The pen will let you edit the slot data. The X will clear the slot. Let's take a look at the edit slot data subpage. This subpage display changes regarding the type of tag. For low frequency tag, there is the UID and the type of tag that will be displayed. For MyFair 1K, we will have way more options showing up. After the name of the badge used in a slot, we can find the type of badge, then the UID. If you are new in RFID pen testing, I'll explain a little more what is doing what. The UID is a sequence of bytes that uniquely identifies an RFID tag or an NFC card. It's pretty much like a serial number for the card. The length of a UID can vary. Common length are 4 bytes, 7 bytes, and 10 bytes. When a reader first communicates with a card, It uses the UID to distinguish that card from all the others. In environments where multiple cards are present, the UID is crucial for the anti-collision process, ensuring that the reader can communicate with each card individually. The UID is generally read during the initial stages of the communication process. Then we have the SAK. SAK means Select Acknowledged. After the initial ATQA response, so bear with me, we will see what is an ATQA response after. If the reader decides to communicate with the tag, it sends a select command to which the tag responds with the SAK. The SAK is a 1-byte response that gives more detailed information about the tag, such as its exact type and capabilities. For instance, it can indicate whether the tag is a simple memory card, a more complex cryptographic card, or a card with other specific features. The SAK helps the reader to understand how it interacts with the card, what protocols to use, and functionalities to expect. Then we have the ATQA. ATQA stands for Answer to Request A. This is a response from an NFC card or RFID tag when it is first activated by a reader's RF field. The ATQA is a 2-byte response that provides the reader with the initial information about the type of card or tag. It includes details like the card's RF technology compatibility and its data transmission rate. The ATQA is part of the card's anti-collision mechanism, helping to ensure that the correct card is identified and communicated with when multiple cards are present in the reader's field. Then you can enter an ATS, Answer to Select. ATS is specific to ISO IEC 14443 Type A cards. After the card has been selected by the reader using the SAK or Select Acknowledge, the card responds with the ATS if it's operating under the ISO IEC 14443-4. The ATS contains information necessary for the initialization of the protocol parameters for further communication. The ATS is important for establishing a more complex communication channel between the reader and the card, especially for cards that perform higher-level functions like secure transactions or data storage. After that, we have the MIFARE Classic emulator settings. Gen 1A Magic Mode. Gen 1A Magic Mode refers to a specialized type of RFID tag that allows for greater flexibility and control over the tag's data, including the ability to rewrite the UID and other normally read-only sections. While useful for research and testing, well, they must be used with consideration for security and legal concerns. Then we have the Gen 2 Magic Mode. Gen 2 Magic tags are compatible with most systems supporting MIFARE Classic cards and offer improved performance. They typically have better security features compared to the Gen 1A tags. Use UID, SAK, and ATQA from ZeroBlock. We'll use the UID, SAK, and ATQA. This functionality is particularly important for custom applications, security testing, and scenarios where specific tag behaviors are required. How does it differ from other fields? Well, some cards report a different UID, SAK, and ATQA to the reader as they have in block 0. By default, the UID, SAK, and ATQA are set to the values read by the Chameleon, but you may want to use the data from block 0 for specific applications. Collect nonces, MFKey32. The process of collecting nonces typically involves interacting with a MIFARE Classic card multiple times to gather enough data, so nonces, for cryptographic analysis. Each interaction involves a challenge and response communication where the card generates a nonce. By collecting these nonces, an attacker can analyze them to find vulnerabilities in a card's security protocol, particularly weaknesses in the random number generation or implementation flows in the encryption algorithm. To use this function, you enable MFKey in the slot settings, then you present the Chameleon Ultra to a reader. Note that it is also working offline, so when there is no app connection, then you return back to the slot settings and there is a new button, Recovered Keys. Another page opens, you can see the number of nonces the keys can be recovered from, press it, and the MFKey32 gets to work. The progress bar is a nice touch. It'll take a moment to recover all the keys. When the keys are recovered, you can of course save them. You have three options: save recovered keys to file, add recovered keys to existing dictionary, and create a new dictionary with the recovered keys. Finally, don't forget to remove the MFKey32 options from the slot you were collecting nonces from. Let's get back to the edit slot data. The last section is the write mode. Normal, the emulation acts like a normal card, accept writes, save them to permanent storage, etc. Decline tells the reader this is a read-only card and decline writing. Deceive accept writes from the reader but don't save them. When the reader tries to read the data again, it's gone, nothing happened, and it didn't actually write. Shadow accept writes and cache them. When the reader tries to read, it's still there, but as soon as the device goes to sleep, it's back to default, as if nothing happened. At the bottom right, you can cancel or save the changes. The saved cards page is composed of two sections: cards, where the cards saved are displayed, and dictionaries, where you can manage the dictionaries. You can add a card using the plus button on top of the section. Simply press the button and browse to add a valid saved card to your computer or phone. Each saved card shows an icon for LF or HF card, the tag name, the type of card, and an edit, save, and delete button. When you press the edit button, you are able to modify the UID and other available fields of the specific card. When done, you have the option to save or cancel the modifications. Save will offer you to save as a .bin or a .json, and the trash icon will let you delete the save tag. In the dictionaries section, you will see the saved dictionaries. It's the number of keys in the dictionary and three buttons: edit, save, and delete. Pressing the edit button will let you edit the dictionary manually. You can add, delete, modify the keys. When you are done, click save or cancel at the bottom of the page. The save button will let you save the dictionary on your computer as a .dic, and the trash icon will erase the dictionary. Adding a dictionary is fairly simple. Press the plus icon at the top of the section and select the file with the stored keys. Let's change page and go to read cards. To read a card or a tag, simply put it very close to the Chameleon and press the read button corresponding to the type of frequency used by this card. If you are not sure, well, just try HF first and then LF. For LF card, once read, you have the option to save the card. You just need to enter a name for that card and press OK. Now the card will show up in the saved cards. For a MyFair high frequency card, you can save only the UID, so no keys will be saved. If you want a dump with all the keys of the cards, you need to check the display keys. A red cross means the key is unknown. A green check mark means that the key is found. Let's take a closer look to the keys section. In order to find the missing keys of a card, you need to use a dictionary. If you select no dictionary, then you won't be able to find them. By default, there is an internal dictionary in the Chameleon. You have the option to skip it though when you check the skip default dictionary function. When you want to use a custom dictionary, under additional key dictionary, select a previously saved dictionary. You can see that by default it is empty. Click and select the dictionary you want to use, then press check keys from dictionary. And the Chameleon is recovering the missing keys. After that, you can dump the card or export the found keys. To save a card dump, press dump card, save, name the card, click OK. Now the card will show up in the saved cards. You can also save the card as a .bin. When you want to save the recovered keys, you have three options. First one, save recovered keys to file. You press enter and enter a name. Second option, add recovered keys to existing dictionary. You have to press and then select the existing dictionary that you want to add the keys to. Third option, create new dictionary with recovered keys. Here you just have to enter the name of the new dictionary that you want to create. Next page, write card. Writing a card is a simple 3-steps process and all the instructions are on the screen. Step number 1, select the card previously saved, then press next. Step number 2, select magic card type. In this section, pick the type of magic card you want to use if you know it. If you're unsure, you can also try the auto-detect magic type function. Press next. Step number 3, write data. Simply press on write data and voila, the Chameleon is writing on the card. And finally, last page, settings. The first section is sidebar expansion. Expand shows the icons and menu titles. Auto automatically expand or retract the sidebar depending on the window size, and retract the sidebar. Then we have the theme section with 3 options. System will pick the system theme, light, the light theme, and dark, the dark theme. Then we have color scheme. You just pick the color you prefer. It works with light and dark theme. Then you have the language, so you just pick the language that you are more comfortable with. Then you have confirm deletions, toggles whether or not to display a confirmation dialog when deleting a card. Then we have export setting. Multiple options there. Cancel if you want to go back to the previous page. QR code. Press it. Then you have access to 2 parameters. Split size and error correction. Split size is the maximum number of characters per QR code. By default, it is set to the maximum size, 2048. The more characters, the less QR codes needs to be generated to export all the settings. Then you have a slider for error corrections. Here as well, as the value increases, more QR codes will be needed to export all settings. Under that, you can find a test QR code. When you press OK, you will see the total number of QR codes needed to fully export the settings to your phone. Here we have 28 QR codes that we will need to scan on our phone to import all the settings from the desktop. JSON file will create a file that you can later import in another GUI. JSON or JavaScript object notation file is a standard text format that is used to store and transport data. As you may already know, it's commonly used in web applications for sending data from a server to a client and vice versa. Next section, import settings, where you choose how you want to import the settings. Once again, 3 options here. Cancel will let you go back to the previous page. QR code, press it and you will be asked to start scanning, then scan the export QR codes from your desktop. JSON, press and choose the .json file with the settings that you want to import from your device. Then we have the About section. It shows the build information of the GUI, the list of developers working on it, the license, a link to the GitHub, and a section to thank the supporters of the project. If you want to support this project yourself, a link will be in the description below. And lastly, the code contributors. And lastly, you can activate the debug mode. When you press it... Oh my god! Oh my god! Okay, we won't go there in this video. Thank you for watching this video. If you found it useful or informative, please like, share and comment, and don't forget to subscribe to this channel. We will make sure to keep you updated when updates will be released for the Chameleon Ultra GUI and the Chameleon Ultra firmwares, so stay tuned. I want to thank again GameTec-Live and the other contributors for their hard work and help to make this video possible. If you want a Chameleon Ultra, a Chameleon Ultra Lite or a Chameleon Dev Kit, with the best price and the best service, visit lab4one.com. Take care and see you next time.